Hello students, welcome to TS Quick Learn. And the next bit in exercise 3.1 is, and this is the new chapter that is playing with numbers. So first bit is, which of the following numbers are divisible by 2, 3 and then 6. So we'll go one by one. We'll check how the divisibility rules work for 2, 3 and 6. So the first question is 3, 2, 1, 7, 2, 9. So the divisibility rule for 2 is, a number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. So in this number 3, 2, 1, 7, 2, 9, no, when we check the divisibility rule, it is not satisfying the condition that 9 is not there in that 0, 2, 4, 6 or 8. So we can directly say that the whole number, that 3, 2, 1, 7, 2, 9 is not divisible by 2. Coming to the next divisibility rule is 3. So for the divisibility rule of 3, if the sum of the digits is divisible by 3, then the number is divisible by 3. That means, what is meant by sum? If we add all the digits of a number, then that number should be divisible by 3. That means that number should be there in the 3 table. It should completely divisible by 3. So if we add 3 plus 2 plus 1 plus 7 plus 2 plus 9, we get 24. And in 3 table, we get 3 8s are 24. That means it is completely divisible. So we can say that 3, 2, 1, 7, 2, 9 is divisible by 3. And coming to the next divisibility rule, that is divisibility by 6. If a number is divisible by both 2 and 3, then it is also divisible by 6. Here they have given that it should be divisible by both 2 and 3. So this particular number is divisible by 3, but it is not divisible by 2. So we can directly say that it is not divisible by 6. Coming to the next divisibility rule, coming to the next bit, and the next bit is 197232. We'll check the divisibility by 2. If you want, you can expand the divisibility rules with the definitions, but here I have given with a small easier way. So divisibility by 2, 197232, the ones place is 2. So according to the divisibility rule, if the ones place is having either 0, 2, 4, 6 or 8, then it is divisible by 2. So that is satisfying this condition. So we can say now 197232 is divisible by 2. And divisibility by 3, 197232, what is the divisibility rule for 3? It is, the sum of the digits should be divisible by 3. If we add all these digits, 1 plus 9 plus 7 plus 2 plus 3 plus 2, then we get 24. And 24 is completely divisible by 3. So 3 8s are 24. It is divisible by 3. And divisibility by 6, the number 197232 is divisible by 2 and 3. Here if we check, it is divisible by 2 and 3. So it is divisible by 6. And the next bit is 972132, divisibility by 2. If we check here, the ones place digit is 2, which is satisfying the condition 0, 2, 4, 6 or 8, any of the numbers. So it is, the end number is ending with 2, that means ones place is 2, so it is divisible by 2. Divisibility by 3, if the sum of the digits is divisible by 3. If we add all these digits, we are getting 24, and 3 8s are 24, which is divisible by 3. And divisibility by 6, the number 9972132 is divisible by 2 and 3. So it is divisible by 6. Coming to the next bit, 1790184, divisibility by 2 is, according to the formula, according to the definition, we say that 0, 2, 4, 6 or 8, right? Here the ones place digit is 4, which is divisible by 2. And divisibility by 3, sum of the digits, if we add the digits, we get 30, and in 3 table we'll get 30. 3 10s are 30. That means it is completely divisible by 3. So the number 1790184 is divisible by 2 and 3. So it is divisible by 6. Coming to the next bit, 312792, divisibility by 2. If we check that in ones place it is 2, that means according to the definition, it should be like 0, 2, 4, 6 or 8, so it is divisible by 2. If we add the digits, we'll get 24, so this is also divisible by 3, so we can say that it is also divisible by 6. Next bit is 80052, divisibility by 2. It is ending with 2, so it is satisfying the definition. The definition is 0, 2, 4, 6 or 8. It is satisfying the definition, so it is divisible by 2. And divisibility by 3, if we add this number, we are not getting the number which is divisible by 3. That means 20 is not divisible by 3, so we can say it is not divisible by 6, because it is satisfying the condition of divisibility rule for 2, but it is not satisfying divisibility by 3. So we can say that 8005552 is not divisible by 6. And the next bit is 4335, divisibility by 2. Here in this case, 4335, ones place is 5, which is not satisfying either 0, 2, 4, 6 or 8. It is not falling under this condition, so it is not divisible by 2. If we do the sum, we are getting 15, and in 3 table we get 3 5s of 15, which is divisible by 3. And divisibility by 6, it is not satisfying the condition for divisibility by 2, so it is not divisible by 6. Next bit is 726352, divisibility by 2. If we check in ones place, it is 2, so it is divisible by 2. And divisibility by 3, if we add all the digits, we get 25, which is not divisible by 3. So here this is not satisfying one of the conditions, that it is not divisible by 3. So we can say that the number 726352 is not divisible by 6. 3.1 is determine which of the following numbers are divisible by 5 and by 10. And the given numbers are 25, 125, 250, 1250, 10205, 70985, 4580. Check whether the numbers that are divisible by 10 are also divisible by 2 and 5. So, in order to understand how the numbers are divisible by 10 and 5, we have to know the divisibility rules of 5, 10 and 2. Okay, and divisibility rule for 5 is the numbers with 0 and 5 at ones place are divisible by 5. If we take the first number 25, in the ones place the digit is 5, so it is satisfying the above condition of the formula, so it is divisible by 5. 25 is divisible by 5, so divisibility rule by 2. A number is divisible by 2 if it has any of the digits 0, 2, 4, 6, 8. So in its ones place. So for 25, in ones place it is 5, so it is not divisible by 2. Divisibility by 10. The number 25 is divisible by 5 but not 2, so it is not divisible by 10. For the divisibility rule for 10, it should be the ones digit should be 0, because if we check the 10 table, every time when we check 10 table, we'll get the last digit. When the ones place digit, it will be always 0. So in 5 table, 5 twos are, if we do, we get 10. Every time if we multiply 5 table with ending with the 2, we'll get 0 in the last. So it is not divisible by 10. Since it is not divisible by 2, we can say it is not divisible by 10. And the next bit is 125. As we now know the divisibility rules by 5, 10 and 2. For 5, what is the divisibility rule? In ones place it should be 5. For 125 it is 5. So it is divisible by 5. And divisibility by 10. In ones place what it should be there? It should be 0. So it is not 0. So we can say that it is not divisible by 10. And the next bit, divisibility by 2. Ones place it is not 0, 2, 4, 6 or 8. That means we can say that it is not divisible by 2. And the next bit is 250. If we check the divisibility by 5, ones place is 0. So for divisibility rule for 5, it might be either 0 or 5. So it is satisfying the condition. So it is divisible by 5. Divisibility by 2. Ones place is 0. That means it is satisfying the condition that it should be either the ones place digit should be either 0, 2, 4, 6 or 8. So it is divisible by 2. And the next bit is divisibility by 10. In ones place it is 0. So the number is divisible by 10 also. And the next bit is 1250. So the number is ending with 0. That means it is divisibility rule for 5 is in ones place it should be either 0 or 5. So it is satisfying the condition. So it is divisible by 5. And the divisibility by 2 is in ones place it is 0, and this one is also satisfying the condition that it should be either 0, 2, 4, 6, 8 or 8. So it is satisfying the condition, so that we can say that it is divisible by 2. Divisibility by 10, ones place it is 0, so it is also divisible by 10. And the next bit is 10205. Divisibility by 5, ones place it is 5, so it is divisible by 5. Divisibility by 10, ones place it is not 0, so it is not divisible by 10. Divisibility by 2, in ones place we have 5, so it is not falling under 0, 2, 4, 6 or 8, so it is not divisible by 2. And the next bit is 70985. Divisibility by 5, if we check, ones place is 5, so it is divisible. If we check the divisibility rule for 10, ones place is 5, which is not divisible by 10. And for divisibility rule of 2 also, it is not falling under the numbers that 0, 2, 4, 6 or 8, so it is not divisible by 2. And next bit is 45880. Divisible by 5, if we check, the number is ending with 0, which is divisible by 5, because the divisibility rule has it should be the ones place digit should be either 0 or 5. Divisibility for 10, ones place should be 0, so it is satisfying the condition, so it is divisible by 10. Divisibility by 2, in ones 2, 4, 6 or 8, so it is satisfying the condition, so it is divisible by 2. So out of all these bits, what can we conclude? If a number has 0 in its ones place, we can blindly say that it will be divisible by 2, 5 and 10. Next bit in exercise 3.1 is fill the table using divisibility test for 3 and 9. So we know the divisibility rule for 3 and 9, right? That if the sum of the digits is divisible by 3, then it is divisible by 3. The number is divisible by 3. And if the sum of the digits is divisible by 9, it is the number is divisible by 9. So the given numbers are 72, 197, 4689, 79875, 988, 974. So if we add first 72, we get 7 plus 2 is 9. In 3 table, we'll get 9. 3 3s are 9. So we can say that it is divisible by 3. And in 9th table also, 9 ones are 9. So we can say that it is divisible by, the 72 number is divisible by 9. Similarly, 197. If we add 1 plus 9 plus 7, we get 17, which is not divisible by 3 and 9 also. And the next one is 4, 6, 8, 9. 4 plus 6 plus 8 plus 9 is equals to 27. We get 27 in 3 table and 9 table. So both are divisible. So the number 4689 is divisible in 3 and 9. 79875. If we add 79875, we get 36, and we get 36 number in 3 table as well as in 9 table. So it is divisible. The 79875 number is divisible in 3 table and 9 table. If we add 988974, we get 9 plus 8 plus 8 plus 9 plus 7 plus 4, we get 45, which is the digit number which is divisible by 3 and 9. So we can say that it is the number 988974 is divisible by 3 and 9. And the next one is make 3 different 3-digit numbers using 198, where each digit can be used only once. Check whether which of these numbers are divisible by 9. So they are asking us to make 3 different 3-digit numbers using 198. That means we can use 198 digits in any of the way, and we have to make different numbers by changing the positions and check whether these are divisible by 9 or not. So If we check the three digits that are given in this question are 198. How can we do different change the positions and get the numbers? We can write it as 198, we can write it as 918, we can write it as 81. That means we can say that uh, we have 198, 918 and 819, and if we check the divisibility rule, a number is divisible by 9 if the sum of the digits of the number is divisible by 9. As we have seen earlier, we have to sum the digits, that means add the digits and check whether the number obtaining after adding is divisible by 9. If we add that 198, that means 1 plus 9 plus 8, we get 18. If we add 918 also, we'll get 18 only, and if we add 819 also, we get the number 18 only, because we are not uh, changing the number, we are just changing the digits, so we get the same answer every time. So when we get the same answer every time it will be divisible by 9. Numbers among 2, 3, 5, 6, 9 divides 1, 2, 3, 4, 5 exactly. Write 1, 2, 3, 4, 5 in reverse order and test now which numbers divide it exactly. Now we have to do the divisibility rule for each and every thing, like 2, 3, 5, 6, 9 for this number 1, 2, 3, 4, 5. As we all know the divisibility rules by now. Divisibility rule for 2 is a number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. If we check 1, 2, 3, 4, 5, it has 5 in its ones place. So it is not divisible by 2. Therefore, we can say that 1, 2, 3, 4, 5 is not divisible by 2. Divisibility by 3 is if the sum of the numbers of the digits is divisible by 3, then the number is divisible by 3. So if we add 1 plus 2 plus 3 plus 4, 4 plus 5 is 15, which is 3 5s are 15, which is divisible by 3. So we can say that 1, 2, 3, 4, 5 is divisible by 3. Divisibility by 5. The numbers with 0 and 5 in it at ones place are divisible by 5. If we check 1, 2, 3, 4, 5, the ones place digit is 5 and it is divisible by 5. 1, 2, 3, 4, 5 is divisible by 5. If we check the divisibility by 6, if a number is divisible by both 2 and 3, then it is also divisible by 6. We have seen in the first bit, right? So 1, 2, 3, 4, 5 is divisible by 3 but not by 2, because we have 5 in ones place. So it is not divisible by 6. Divisibility by 9. A number is divisible by 9 if the sum of the digits of the number is divisible by 9. So 1 plus 2 plus 3 plus 4 plus 5 is 15, but it is not divisible by 9 because 15 is not there in the 9 table. That means 15 is not divisible by 9 table. So it is not necessary that if it is divisible by 3, it should be divisible by 9. Therefore 1, 2, 3, 4, 5 is not divisible by 9. So in the question they have asked to check in the reverse order. What is the reverse order of 1, 2, 3, 4, 5? It is 5, 4, 3, 2, 1. Divisibility by 2, if we check, it is the number is ending with 1 and the ones place digit is not falling under 0, 2, 4, 6 or 8. So it is not divisible by 2. And the divisibility by 3. 5, 4, 3, 2, 1. If we add 5, 4, 3, 2, 1, we get 15. This also will be divisible because even the reverse order changes, the sum of the digits will be same. So we can say that the sum of the digits is 15, which is divisible by 3, because 15 is divisible by 3. Divisibility by 5. If we check, since the order changed, the number ones place digit is 1. But this is also not falling under the condition that it should be either 0 or 5. So it is not divisible by 5. And the last one is divisibility by 6. 5, 4, 3, 2, 1 is divisible by 3 but not divisible by 2. Therefore, it is not divisible by 6. It should satisfy both the conditions, but it is not satisfying the divisibility rule of 2 since the ones place digit is 1. So it is not divisible by 6. Divisibility by 9. If we add these numbers, we get 15 and 15 is not divisible by 9. So we can say that 5, 4, 3, 2, 1 is not divisible by 9. Thank you. Write different 2-digit numbers using digits 3, 4, 5, which check whether these numbers are divisible by 2, 3, 5, 6 and 9. So similarly, like the previous one, we have to write different numbers formed by the digits 3, 4, 5, and we can write the digits as follows: 34, 45, 43, 54, 53, 35. So if you check the divisibility rule for 2, it should be the ones place to digit should be 0, 2, 4, 6 or 8. So it is falling under the condition. So we can say that it is divisible by 2. Divisibility by 3 is sum of the digits. 3 plus 4 is equals to 7, which is not divisible by 3. And divisibility by 5 is the ones place digit is not equal to 0 or 5. So we can say that 34 is not divisible by 5. So next one is divisibility by 6. 34 is divisible by 2 but not divisible by 3. So we can say it as it is not divisible by 6. Divisibility by 9. Sum of the digits is 3 plus 4 is 9. So the 3 plus 4 is 7. 7 is not divisible by 9. So we can say 34 is not divisible by 9. Similarly, for the next one, 45, divisibility by 2. Since the ones place digit is not falling under the condition 0, 2, 4, 6 or 8, so 45 is not divisible by 2. Divisibility by 3. If we add the digits, we get 9, and 9 is divisible by 3. So we can say 45 is divisible by 3. Divisibility by 5. Ones place digit is 5. So according to the divisibility rule for 5, it should be either 0 or 5. So 45 is divisible by 5. Divisibility by 6. It should satisfy both the conditions of the divisibility rules that it is should be divisible by 3 and should be divisible by 2. But it is not satisfying the condition for divisibility by 2. So we can say 45 is not divisible by 6. Divisibility by 9. If we add the digits, we get 9, and 9 is divisible by 9. So we can say that the number 45 is divisible by 9. So we can say that 45 is divisible by 9. And the next one is 43, divisibility by 2. 43 is ones place digit is 3, which is not falling under the condition 0, 2, 4, 6 or 8. So 43 is not divisible by 2. Divisibility by 3. If we add, we get 7, which is not divisible by 3. Divisibility by 5. If the number is not ending with 0 or 5, so 43 is not divisible by 5. So divisibility by 6. It is not satisfying the condition of 0, 2, 4, 6 or 8. So it is not divisible by 2. So we can say that 43 is not divisible by 6. Divisibility by 9. If we add the digits, we get 9, and it is also not divisible by 9. The next one is 54. If we check the ones place digit, it is 4. So it is falling under the condition 0, 2, 4, 6 or 8. So 54 is divisible by 2. Divisibility by 3. If we add the digits, we get 9, and which is divisible by 3. Next one is 35. Divisibility by 2. Ones place digit is 5, which is not equal to 0, 2, 4, 6 or 8. So 35 is not divisible by 2. Divisibility by 3 is if we add the digits, we get 8, which is not divisible by 3. Divisibility by 5. The number is ending with 0 or 5. It is falling under the condition, so 35 is divisible by 5. Divisibility by 6. 35 is not divisible by 2 and not divisible by 3 as well. So we can directly say that it is not divisible by 6. Divisibility by 9. If we add the digits, we get 8, which is not divisible by 9. So we can say that 35 is not divisible by 9. Thank you. Write the smallest number or digit and the greatest possible digit in the blank space of each of the following numbers so that the number formed are divisible by 3. So the possible digits are, for the first bit, the possible digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? If we check the numbers, we can put in that blank space, we can put either 0, 1, 2, 3, 4, 5, 6, 7 or 8. We cannot put any other digits in that blank space. So we'll check whether if we put a 0, then what happens? The number becomes 0, 6, 7, 2, 4. If we check the divisibility rule for 3, the sum of the digits is divisible by 3 means we can say that it is divisible by 3. 0 plus 6 plus 7 plus 2 plus 4 is 19. So 19 is not divisible by 3. So it is not divisible by 3, so we can go for another digit is 1. If we put 1, then the number becomes 16724. If we add those, sum of the digits is 20. That is also not divisible. If we'll check for 2. If we put 2, then if we add 26124, then we get 21, and it is divisible by 21 is divisible by 3. So the number found by the smallest digit which is divisible by 3 is 26724. Why are we saying smallest digit? Because if you put 3 also, 36724 also, but that is not the smallest possible digit. The smallest possible digit is 2. So we don't have to check for other numbers. Since it is the order is already perfect, we are not checking for the other numbers. 2 is the smallest possible digit. So next, we'll check for greatest possible digit. If we go in ascending order, then 0 1 2 like that will get smallest. If we go in reverse order, that means 9 8 7 6 like that, then we get the greatest possible digit. So we'll put 9 and check. If we put 9 and check, the number becomes 9 plus 6 plus 7 plus 2 plus 4, and 28 is not divisible by 3. Step 2. If we check, if we put 8 and check, 8 plus 6 plus 7 plus 2 plus 4, which is 27, which is divisible by 3. We can say that 8627724 is the greatest, it is divisible by 3. So the smallest possible digits are 2 and 8. Similarly for the next bit, here the blank space is in another place. So the possible digits in ascending order, we'll check in ascending order: 0 1 2 3 4 5 6 7 8 or 9. Those are the possible digits. If we put 0, then what happens? If we put 0 in that blank space and then add, we get 24. 24 is divisible by 3, right? So 476502 is divisible by 3. The smallest possible digit which is divisible by 3 is 0 itself. So when we check for greatest possible digit, the number 9, if we check, we have to, if we have to know what is the greatest possible digit, we have to come in the descending order. That is 9 divisibility by 3. Sum of the digits is 4 plus 7 plus 6 plus 5 plus 9 plus 2 is 33. 33 is divisible by 3. So we can say that this is divisible by 3. The greatest possible digit is 9 and the smallest possible digit is 0. Next bit is 7221 blank space 5. So possible digits are these things. And step 1, if we put 0 and then add, we get 17, and which is not divisible by 3. If we put 1, if we add, we get 18, and 18 is divisible by 3. So we can say that the smallest possible digit is 1. Now since we got the smallest possible digit, we'll check greatest possible digit. If we have to check the greatest possible digit, we have to go in the reverse direction. That is, if we put 9, if we add the numbers, we'll get 26, which is not divisible by 3. If we put 8 and check, we get 25, that is also not divisible by 3. So if we check 7, we get 24, which is divisible by 3. So we can stop the process and we can say that the smallest possible digit which is divisible by 3 is 1, and the greatest possible digit which is divisible by 3 is 7. Thank you. 8th bit, which is find the smallest number that must be added to 123 so that it becomes exactly divisible by 5. So we can add the possible digits is 0 1 2 3 4 5 6 7 or 8 8 and 9. So we can add any of the digits. So if we check, if we add 0, we'll get 123 only, which is not divisible by 5. If we add 1, we get 124. That is also not divisible by 5 because the number is not ending with 0 or 5. If we add 2, then we get 125, which is divisible by 0 or 5. Since they asked in the question that the smallest possible number, what is that smallest number? If we add 2 to 123, it becomes 123 plus 2, which is 125. The ones place digit should be either 0 or 5. So it is satisfying the condition. So we can say that the smallest number which can be added, which is exactly divisible by 5, is 2. Coming to the next question, find the smallest number that has to be subtracted from 256 so that it becomes exactly divisible by 10. So if the number has 0 in its ones place, it should be divisible by 10. But here we have 256. They are asking the smallest possible number which can be subtracted. So we can do in the previous method also or in this method also, but that process will become more. So that is a big process. So if we could do this in this way, if we divide 256 with 10, then the remainder will be 6. If we remove that 6, if since they are asking to for us to subtract, if we remove the 6, if we divide this 256 with 256 with 10, we get the remainder 6. So if we subtract 6 from this 256, the number becomes 250, and it will be exactly divisible by 10, because the number should contain 0, or the number should be 0 in its ones place, then only it will be divisible by 10. Thus, so therefore the smallest number that has to be subtracted from 256 so that it becomes exactly divisible by 10 is 6. Thank you.